We'll talk about prime factorization in this video, and before we can talk about prime factorization, let's first take a look at what do we mean by factors. So let's think about a number, for example, 21. Now think of all the different ways in which you can write 21 as a multiplication. So it's 1 times 21, and it's also 3 times 7. So when I look at these numbers 1, 3, 7, and 21, these are the numbers which will completely divide 21. So these are called factors of 21. So what are factors of a number? These are numbers which will completely divide a given number. Now, for example, what are the factors of 24? We can write 24 as 1 times 24. We can also write it as 2 times 12. We can write it as 3 times 8. We can write it as 4 times 6. So this gives me the complete list of the factors of 24. 1, 2, 3, 4, 6, 8, 12, and 24. So there's my complete list of factors of 24. Let's see an example. 36. So what are the complete list of factors of 36? I can write 36 as 1 times 36. It's also 2 times 18. It's also 3 times 12. It's also 4 times 9. And it's also 6 times 6. So the list of factors of 36 is 1, 2, 3, 4, 6, 9, 18, and 36. Now let's look at some numbers which are unique in that, for example, if I look at number 31, the only way I can write the number 31 as a multiplication is 1 times 31. There's no other way to write 31 as a multiplication. For example, the number 41 is 1 times 41. For example, the number 43 is 1 times 43. So these numbers are unique in that you cannot write these numbers in any other way as a multiplication. So 31 has only 2 factors, 1 and 31. 41 has only 2 factors, 1 and 41. And in the same way, 43 has only 2 factors, 1 and 43. Such numbers are called prime numbers. So prime numbers whose only factors are 1 and themselves are prime numbers. So here are some prime numbers. These are less than 50. And if you can try to write more of those numbers up to 100, so see if you can write all of those prime numbers less than 100. Now some interesting prime numbers differ by 2. So 3, 5 is an example, 5 and 7 is another example, 11, 13 is another example, 17, 19 is an example. These are prime numbers that differ by 2. They're called prime pairs. So consecutive primes that differ by 2 are called prime pairs. Now, all other numbers which can be expressed in multiple number of ways as a multiplication are called composite numbers. So numbers that are not prime. So here are some examples of composite numbers. 4 can be written as 1 times 4. It can also be written as 2 times 2. 6 can be written as 1 times 6. It can also be written as 2 times 3. 8 can be written as 1 times 8. It can also be written as 2 times 4. So all of these numbers can be written in multiple ways as multiplications, and therefore they're called composite numbers. We come to the concept of prime factorization. What does prime factorization mean? It means to express a number as a product of primes. So let's take an example. So we want to do the prime factorization of 144. You can write 144 as a multiplication of 12 and 12. But then we realize that 12 itself is a product of 3 and 4. So each of those 12s can be written as 3 times 4. And then 4 is a product of 2 and 2. So we can expand this further and we can write this as 3 times 2 times 2 times 3 times 2 times 2. That's a mouthful to say. But now what we have here in the last line is only prime numbers. 3 is a prime number, 2 is a prime number. A short way of writing these numbers is this kind of long multiplication is to use exponents. So I can write this as 2 power 4 times 3 power 2. 2 power 4 because 2 gets multiplied by itself 4 times. and 3 power 2 because 3 gets multiplied by itself 2 times. So this is how you would write prime factorization for 144, 2 times 4, 2 power 4 times 3 power 2. Now, factor tree is a visual way of writing the prime factorization. So for example, I could start with the same example here, 144, and then I can say 144, the tree will have 2 branches. So 12 times 12 gives me 144, and then underneath each 12 I can say 12 equals 3 times 4. So 12, the other 12 also equals 3 times 4, and then each of those 4s can be written as 2 times 2. So every time you hit a prime number, just for your ease, what you can do is you can put a circle around it so that you can actually see that these are my prime factors. And then once you have all the numbers encircled and you cannot branch out any further, then you go and you see that there are 4 2's. So we can write 144 is 2 to the power 4, and then times, there are 2 3's, so times 3 to the power 2. So a factor tree is a visual method of writing and finding prime factorization. So let's see if we can do the prime factorization for 20. So we start with 20, and 20 is 2 times 10. Let's start there. Well, off the bat, I can say that 2 is a prime, and then 10 can be written as 2 times 5, and both 2 and 5 are primes. So I have my prime factorization for 20, which is 2 to the power 2, and then times 5 to the power 1, which we do not need to write. So this is how you do the prime factorization of 20. Let's do the prime factorization for 72. Now it doesn't matter, you can think of any 2 numbers which multiply to give 72. So for example, I could start with 6 times 12, and then I can further branch the 6 into 2 times 3, and then 2 and 3 are both primes, so I can put circles around them. 12 I can write as 2 times 6, and 2 is again a prime, and then I can branch the 6 into 2 times 3. So there is another prime, there is another prime right here. So I can say 72 equals, how many times do I see a 2 here? 1, 2, 3. So this would be 2 to the power 3. And then times, how many times do I see a 3 here? 2 times, so 3 power 2. So that's how you do prime factorization of 72. Let's see if we can do the prime factorization for 84. So 84 is 2 times 42. And then this 2 is a prime number. And then 42 is 6 times 7. Oh, 7 is a prime number. And then 6 is 2 times 3, where both 2 and 3 are prime numbers. So we can just put circles around the 2 and the 3. So now I can write 84 as a multiplication of prime numbers. I can say 84 is 2 squared times 3 times 7. So there's my prime factorization for 82. Let's do the prime factorization for 120. So 120 is 12 times 10, and then 12 is 6 times 2. So 2 is a prime number. And then 6 is 2 times 3. So 2 is a prime, and 3 is a prime, and then 10 is 2 times 5. So 2 is a prime and 5 is a prime. So how do I write the prime factorization for 120? I see in my tree there are 3 2's, so 2 to the power 3. There's only one 3, so times 3. And there's only one 5, so there's my prime factorization for 120. If you like this video, please hit the thumbs up sign, subscribe to this channel, and don't forget to turn notifications on by hitting the bell icon. We need your input to decide video topics. Write an email to info@sageeducational.com if you'd like us to create a video on a topic. We will also produce video solutions to questions that you send to info@sageeducational.com. Contact us if you need academic help. We provide in-person and online tutoring for all subjects.